Thank you for being here, staying here for this bit. And thank you for coming to my talk on supporting multi-cloud apps at Stack Overflow, which is an experience report of the things that we're doing at the minute in Stack. So I've got a question for anyone here. Is anyone here also a platform engineer and deploys to multiple clouds? Yeah, I thought not. You really shouldn't be doing that, should you? But if you were going to do it like we're doing it, this is how we're doing it. So I wanted to share that information with you. So a little bit about me first while we continue. So yeah, my name is Chris, Senior Platform Engineer at Stack Overflow, been there 3 years, and I've worked at a variety of places and written a bunch of stuff and whatever, blah, blah, blah. Give you a brief outline of the talk, so you know if you're in the right place, and if you're not, there's other talks, that's absolutely fine. So I'm going to talk about Stack's move to the cloud, a little bit about the multi-cloud problem, deployment problem I want to talk about, a brief intro into platform engineering if you are new to that concept, our platform metadata, the run tool and the invocation image, this will all make sense, and the future of where we're going. And like I say, this is a deployment-focused platform engineering talk. There's going to be lots of YAML, and if that's not for you, again, this is maybe not the talk for you. That's fine. Still with me? Excellent. OK, so Stack Overflow's architecture over time. So we have 3 main products. Now, we all know one of the products, and that's the public website. That is the Stack Q&A site that everyone's fully aware of. And you've all been to, I hope, recently. Come and ask questions. Yay. And we've also got 2 other products that you may not be aware of. They are Business and Enterprise. So Business is the private Stack Overflow for your company's questions and answers, which is multi-tenanted. But if you really, really wanted it yourself, you've got the enterprise version, which is a dedicated instance of Stack Overflow, complete with all the ISO certifications that you maybe needed if you work in a bank or whatever. So we offer that one too. And everyone knows we have a monolith. Like, it's very well known, it's very famous, to the point that people have written YouTube talks about it, articles, documents, Hacker News, we constantly go to the top, that people are still surprised that even now we have a monolith. And that we've been running it in on-prem service, or at least we were running it in on-prem service. So how did we get from that, which we were quite proud of and everyone's talking about, into this multi-cloud situation I want to talk about today? So we first started off with deploying it to Azure. As you would, right? We're a .NET place, we've got C# and SQL Server, so that's where we started. And then in February 2024, we entered a partnership with Google so that we could work with them on that AI integration. And then we thought we'd put the public site on GCP as well, so 2 clouds. Thanks. But we'd already, I kind of lied a tiny bit, we already had our enterprise product on Azure because that's how we got the independent, dedicated instances for the hundreds of customers that needed it. So we had a little bit of cloud experience, but it wasn't quite the same thing. It was like virtual machines, all kind of set up as individual pieces. So we started migrating to the cloud in 2021. And it took us 2 years. And these 2 articles that I've got here go into quite a bit of depth of what we did. So if you're really interested in that journey, you can take a good read on these. Here's a quote that I quite like from it, which explains why we did this move. Our engineers should focus on what adds the most value to our customers, and that's not maintaining physical infrastructure. So again, we succumbed to what everyone else said, move to the cloud, outsource that. And like I said, in 2024, we moved our public site to GCP. And that article is also available, goes in full depth about what kind of stuff, how that journey went. And that one, we'd learned things, only took us 1 year. So improvement. And another quote that I think is great is like, we made the decision to run older applications on a Windows Kubernetes cluster. This was not ideal, but at least it allowed us to avoid running VMs for applications and keep our infrastructure fully on Kubernetes. So we made some choices, let's put it that way, to get this into the cloud. And so it looks something like this at the end. We had the 2 products that are private on Azure and the public site on GCP. But obviously that's a bit interesting, these 3 different ways of doing things, and a storm was basically brewing and how we can deal with this. Now, clouds offer the same products, the same kind of services, but they're different. If you've ever gone from one to another, you've got like different names, but they apparently do the same thing, but they also work slightly differently. So again, everything felt the same, but everything was supposed to be the same, but worked differently. So in Azure, you talk about subscriptions, and in GCP, everything's a project. And you get like regional VNets in Azure, whilst you've got global VPC in Google, which really messed us up. That one's quite ahead. And you've got virtual machines versus compute engine, so they don't quite work the same. So we slapped some Kubernetes on it. But hey, now we have a layer on top where the developers never have to worry about any of that kind of stuff. It all works the same. But if you're an infrastructure engineer, they do not work the same. You think like GKE and AKS are actually quite different. But at least the developers don't have to worry about it anymore. So I want to talk a bit about our infrastructure from a deployment perspective now. A little bit more about this multi-cloud problem. So the monolith is deployed to 3 environments, 1 on GCP, 2 on Azure. And Kubernetes has standardized the app runtime, but we still need to know more of the infrastructure details at deploy time in order for it to work. You still need to know the name of the Kubernetes cluster, where the IP address of the Redis was, where the SQL server was, database connection strings, all that kind of stuff. So you still had this problem. So I want to zoom out a little bit, because that was too much information on that diagram. 3 products. And you may not be aware, but we've actually started to break up the monolith into services. So hooray, it's not just a monolith anymore, we're trying to slowly pull it apart, which means we've got little services that go with that monolith and also have to be deployed to those 3 environments. But not every service goes everywhere. That would be easy, right? So the enterprise service has a different search, for instance, than the public service. So you've got to know which one goes where and all that kind of configuration. So that already is quite a lot to manage. And then you double it up again when you've got dev environments and UAT environments, and it all just kind of like triples and doubles. And even then, the enterprise customers, they're individual, and they've got hundreds of those. It's complete madness. So, yes, complete madness, yes. Right, while we're doing that, I want to have a little bit of talk about platform engineering. So this book came out a couple of years ago, and it really helped us change the way we're thinking about this. So I wanted to give a little succinct overview of that book in the context of this problem that we're having. So it talks about reducing cognitive load for the developers. So developers, up until, at least in our world, were expected to be experts in Kubernetes, IAM, Terraform, security, and write features. So this book talks about reducing that load if you can. It also talks about building abstractions on top of the cloud infrastructure you've got on the platform. So you don't just say, here's your AWS keys or your Azure keys, go have fun. You try and create a curated API which reduces that complexity. And then you try and create a paved path, a way that has the best way for your company to monitor, deploy, and scale your apps. Then you make that path so attractive that developers want to work on it. And finally, you treat the platform as a product. And what we mean by that is that, I know that I didn't get any hands for platform engineers, but when there's been large infrastructure changes and it's treated like a project with an end date, it will be fine until that end date and then it will fall apart suddenly. I'm sure you've worked with something where someone's like, yay, moving to the new, I don't know, CI server, and you spend months doing it and then forgotten about. So by treating it as a product instead, you've got that idea of a life cycle, an evolution, you've got customers, you've got owners, and you need to basically turn it around so that you talk to developers like their customers. And it makes your platform grow rather than become stale and become this emergency thing to deal with all the time. You may have heard of you build it, you run it. I used to be quite a big proponent of that. But it's to try and evolve past that, because there's too much of a heavy burden on developers to know all of that stuff as well as writing features. So this is like one evolution on top of that. So with all of that stuff from the platform engineering book in mind, combined with all of the infrastructure and deployment problems and multi-cloud situation I just talked about, we sat down and tried to think of some goals for what we wanted to do. We wanted to see if we could centralize our infrastructure definitions so that we had one place to go and find infrastructure stuff. You didn't have to have it repeated in every single project, every single service, and doubled up everywhere. We also wanted to standardize our deployment pipeline, because those 3 products were migrated at 3 different points in time. They had 3 different ways of working. we wanted to have the same deployment package across all of those products, so you don't have like a separate rebuild for each one. And finally, we wanted to reduce the developer overhead when targeting the multiple clouds, because it is quite a lot to worry about. I want to go back a bit in time and talk about how it looked like when we first moved to Azure for that middle product, the Teams one. So you can see kind of where we came from. Yeah, that one business. So the initial idea when we tackled this was that in the repository, we'd have the application code, some GitHub actions, some Terraform, and some Customize. If you're not aware what Customize is, it's a kind of parser, I guess, or a merger to create Kubernetes manifests. It's like Helm minus minus. So it's a really simple way of doing Kubernetes manifests and migrating them together for environments. And you just end up with like YAML all over the place in order to do this. And it's copied across every app, so that kind of like, they have a copy of the configuration for each environment that they deploy to, spread out all over the place. And Customize also works with static files, so it needs to know in advance what stuff is merging together. It's almost like a mail merge, which meant that if you were doing something like creating a new piece of infrastructure, a new blob storage or something like that, you couldn't create that, have it output from the Terraform, and have Customize absorb that and use it. It meant that you were down to individual deployment steps in order to add something new on the infrastructure, which was painful. And then you had to do it for every single environment you were deploying to. So Customize wasn't quite giving us what we needed. But before we could continue with anything else, we had to agree what we were talking about, what our words actually mean across those three teams. So those three products, like I say, were migrated by 3 different teams, 3 different points in time, and they had 3 different ways of thinking about it, which meant there was a lot of this going on. If you've seen, this has been The Princess Bride. If you haven't seen it, it's very fun. Do look it up. So we had to sit down and we had to standardize our terminology before we could even go any further. We had to know what we were talking about. So we created the concepts that are in here. We had the concept of a deployment group. So that's like the landing zone or the project, which we would give it kind of names like that would be like the main, the WinMain, that Windows version of it. Or in the case of enterprise, the Acme client, which would live inside an environment. That one's easy. That's dev, that's UAT, that's prod. And all of those would be tied to a product. And in this instance, we had made a decision of a one-to-one concept, that a product and its deployment location were the same thing. So if you were deploying to the public product, it was the one particular infrastructure. There was no cross-cloud communication. If you were talking to the public product, you were deployed next to it. If you were talking to the enterprise product, you were deployed next to it. So that became an infrastructure piece of terminology for us. And cloud, obviously that's the easy one, right? And it goes down. So the cloud has a product, has an environment, has deployment groups. It's in picture format, so it looks more like this. So there's your cloud, pretty obvious. There's your product concept, and your environment concept, where you duplicate it out for dev and prod and UAT, and your deployment group, which for the case of most places is a one-to-one mapping. You know, for the product, for the public one, it's the public one. But for the enterprise, again, it's per client, which is where some of that communication mishaps were happening too. Had to get the words down. But now that we've figured out the words, what do we do now? We all talk the same language, so that helped. Well, you basically invert the problem. You give it a bit of an uno reverso. So I don't know if you can see it there, but it's a tiny little uno reverso card, which basically means no you, which I thought was pretty cool. So what we want to do is get the infrastructure, instead of us going and querying it and writing it into our static files, we got the infrastructure to tell us what it's made of. So we called that publishing the infrastructure metadata. Okay. So the infrastructure engineers, they build the infrastructure at the lower level using Terraform. Cool, and they're familiar with that, and that's how they like working. That's how they put together the Kubernetes clusters, the SQL Server, those kind of bits and pieces. So at the same time as building that, they would take all those outputs that were created, put them into some YAML files and publish them to GitHub. And we created a little custom module that we put into all of this, which does that little output. So when the SQL Server is created, ends up as an output, ends up in the YAML. Here's an example of one of those YAMLs. Here the YAML begins. So the public product in Google Cloud may have infrastructure that looks like this. But if you're in the enterprise product, in the Azure Cloud, I have infrastructure that looks like this. And what you've got here is the world's worst. Spot the difference. Woohoo! So I laid them out for you. Okay, so at the top here, you've got your cloud. Again, they vary. You know where you're going to. The deployment groups. Your product, where you're heading. SOE stands for Stack Overflow Enterprise. And in this instance, the public product has a Redis instance, which we don't have on this enterprise instance. And the host names are different to include the product, to include the client details over there, and some provider-specific stuff. So this is what, when the Terraform is being run by those infra engineers, gets pushed into the GitHub repo. So did this solve our problem? Did this mean that nobody had to have copies of all the infrastructure information everywhere, all over the place? We just grab it instead? Well, yes, it did. But it also made a new problem. Every single app was given every copy of every part of the info metadata for the context it was interested in, so we didn't know what they were using. As far as we were concerned, we'd created this locking now, so that the infrastructure engineers were too afraid to change much in case they messed up the info metadata and all the apps couldn't deploy. So we just create this brand new. So instead, to make this work a little better, we decided to create some app-specific info metadata, more YAML. But this makes sense. What this is a kind of abstraction, a layer on top of the existing infrastructure metadata, which is just for your app saying, I want those values, please. And at deploy time, we'll kind of merge that together. We'll run that grab selection, and the app will only take the bits it wants. And it allows them to kind of evolve independently of each other. So that's pretty cool. So I'm going to show you some variables now, some pipeline variables is what we called them. So here's an example here for an example app. And it needs a Kubernetes ingress host. And our syntax here is grab, and then you've got a kind of hierarchy. Grab from the Kubernetes ingress, blah, 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 blah. And then you've got here, grab the deployment target from blah, 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 blah. And then we've got this one here, overridden in overlays for Terraform. Now, that's interesting. That one's a little bit special. So we'll take a little bit closer look at that. Overlays are a concept that we created that allow you to have kind of context-specific versions of that pipeline variable metadata. So that if you know you're targeting GCP, I want these GCP-specific parts of that information. Because in this instance, Terraform usually lives in a bucket or in a blob storage, depending on where you're going. And you need to know their different values. You don't want both of them. They don't all apply. So on an overlay in the GCP world, you get this. And in the Azure world, you get that. As a reminder of the earlier infrastructure metadata, I forgot to mention, I purposely color-coded them and wrote in the corners which one it is. So it might help you tell your YAMLs apart. So this is the one the infrastructure creates. And these are the bits that we are going to grab from it. And that's what it would render for our app. So instead of getting the whole giant infrastructure metadata it doesn't need, it only gets these ones now. So. How do we run all this? Conceptually it makes sense. You have this, and you do that, and there's a mapping on top of that. But how do we use this in practical? We wrote our own custom tool in Go to do it. So what that custom tool does is it takes those infrastructure metadatas in orange, those pipeline app-specific metadatas over here. It takes your Terraform, your Helm charts. Oh yes, we moved to Helm. Needed that. Forgot that bit. It takes the context of where you're deploying, puts that all together into your Go tool, where it will then merge, pick only the overlays you're interested in. Like I said before, if you're deploying to GCP, you only want the GCP overlays. If you're deploying to Azure, you only want the Azure overlays. Render those together to get that static version, the shortened version. And then we'll run your Terraform and your Helm using those values. And out pops Terraform plan and your Kubernetes manifests. So we've now separated the infrastructure from the app. So deployment time, how does this work? Well, we're using something called CNAB. You may not have heard CNAB, Cloud Native Application Bundles. It's another spec from the Cloud Native Foundation. And it's kind of like a specification for packaging apps up. And it's designed to work pretty much anywhere, including like air-gapped environments. So it has everything included in it. It's a pretty interesting spec. It includes like a bundle JSON describing everything in it, an invocation image, an app image, that's the one that's your application running, and like extra credentials and keys or whatever you might need. But we threw all that away and just wanted the invocation image. So we're not actually following the CNAB spec at all. We just found that one little bit to be useful to us. So let's talk a little bit about just the invocation image spec. What that is as a Docker image, as you can imagine. Includes all of your runtime metadata, so your Helm charts, your Terraform templates. And then it has a little, like, what they call a run tool inside it. And this is part of the spec, run tool. And that must run what they call actions. And those 3 actions are install, upgrade, and uninstall. And that's the spec for an invocation image. Pretty vague. But all it means is that you just need a Docker image that can listen to those 4 commands. And the simplest it could look is something like this, which is just a bash script. You know, just like if you hear install, echo install. If you hear uninstall, echo uninstall. So they still call that a run tool. Pretty big name for a bash script. But our version. Oh, wait, one more bit. So what happens is that you build this Docker image with this run tool and these uninstall and install commands, and you just run that same image over and over with where install, uninstall, wherever you are. So if you're in that air-gapped environment, you would run your install and your uninstall. So our version of the Stack Overflow invocation image. Again, we start with a Docker image. And to make it easier on our developers, we have a base image where we've pre-baked in Terraform, Helm, and our Go run tool, which is it does the same thing. It listens to the install, the upgrade, does all that merging of all the infrastructure metadata. And the app developers will then bake in their Terraform and Helm charts on top. And then as part of your CI/CD pipeline, you will generate 2 images. Previously, you generate just 1 image, which is your app, but you now generate this CNAB image at the same time. And you stamp it with the same version number because it is a version of your infrastructure that matches this app. And then when you deploy, you actually only run the CNAB image, the invocation image, I apologize, which is what will then deploy your application into the cloud. So when you're trying to deploy with this image, what you do is, again, you pass in your infrastructure metadata, your pipeline metadata, the context of where you're sending it to, and the invocation image is action. So this looks like the same stuff as earlier, but now it's wrapped in Docker. And so what does it look like from an app perspective now? So I'm going to show you some folder structures. I think in folder structures. If I can't, I can't. So we've got some folders here. What we have is this hierarchy with these values. So in the Helm level, we've got the lowest hierarchy, highest hierarchy, I suppose, which has application variables that point to everything. So the host name, every cloud, everything needs a host name. And then under that, we've got cloud-specific ones. So we've got the Azure folder, the GCP folder, and these will be your cloud-specific overlays. These are pipeline variables. And then you'll have like environment-specific ones. So there's a low replicant count in dev, or in prod, you can have higher resources and so on. And these are what all get merged together. So what I've done now is that if there is ever an infrastructure change at all the infrastructure engineers do is change their Terraform over here. It publishes a new version of this YAML down here, and then we just redeploy the app. Because whenever the app is deployed now, it just uses the latest version of the infrastructure metadata to run the same stuff. So, to go back to our goals, did we achieve them? That's our question. Did we centralize our infrastructure definitions? I think we did. Did we standardize our deployment pipeline? Definitely. We've got that invocation image, that run tool. We also have the same deployment package no matter where you go because the context is extracted out of it. Did we reduce developer overhead Not really. That one we screwed up on, I would say. We've now got all those overlays. It's really hard for people to grok what's going on. They don't know what the final manifest is going to look like. So we kind of like, okay, 2 steps forward, 1 step back. Okay, definitely something for us to fix. So this is actually the state we're in right now. This is the story up to date. We're in what we call the messy middle. And there are a lot of things that we want to improve, a lot of things we want to change, a lot of things on our platform as a product that we want to work on. One of the things is the local development. We've got some CLI tools also written in Go that can do that merging and flattening for you, but everyone has to go and download, install them, learn how to run them. So it's not great. And in fact, people don't even want to be dealing with any of the Terraform either. So we're going to look into something called Kratix. I don't know if you've heard of it, but it turns kind of everything into a kind of Kubernetes operator almost. It's like an alternative to, what is the other one called? Yes, you run the infrastructure through Kubernetes. So hopefully, yeah, very much like cross-plane, but a slightly different course of action. So it's done with promises rather than operators. So that one, we're going to look into that one. And then hopefully the developers will have even less to worry about in terms of infrastructure. And we're also going to look into getting Aspire going, because what we've created is such a weird, complicated kind of like infrastructure with all these overlays and everything, that if we can hook it up to something like Aspire to make it all run, that'll hopefully make everything easier for them too. Okay, so, I've gone quicker than I expected. Right, so what can you guys take away from the journey of what we've just talked about today? I do think that having a shared language was really essential. We've got quite a few documents with just terminology in them and discussions thereof. Without that, I think you wouldn't be able to write the YAML or the infrastructure because you wouldn't even know what the words meant. So step 1, the ubiquitous language. We needed to move the cloud complexity from where it was in every single app, most of the way there, into the platform itself. And like I say, most of the way there. But don't forget the local dev experience. That's not going to make anybody very happy if you kind of make that tougher on them. So, yeah, we have plans for that. So I think we're going to have a brighter future ahead. Yeah. And annoyingly, I run through that very, very quickly. Sorry about that. Thank you. I can give you more YAML if you like. Woo! Does anyone have any questions? No, way too much YAML. Okay. Yeah, I finished that way too early. I think there's like another, Jesus, there's like half an hour left. How did I do that? Sorry? Again, yeah, I could fit it in twice. I apologize, I really do. Yeah, okay. You could ask about Kratix, yeah. We have started investigating it, yeah. We started doing some POCs internally. What would you like to know? Okay. Yeah, so Kratix is a relatively new thing on the scene, like I say, instead of like cross-plane, but it does that same sort of thing where you talk through Kubernetes, through manifests in order to create the infrastructure. And the idea is that your infrastructure team puts together what they call promises, so a way of deploying the infrastructure. So you write the Terraform, you write the whatever you want to do, lump it up into this Kratix promise, and then the apps say, give me one of your Stack Overflow databases. But it looks like a piece of Kubernetes manifest at the top. So they end up with like 5 lines of, I want a database this big with this much. And behind the scenes, Kratix will take that and run the pre-developed promise to build your database. So we're hoping, because even though I don't mind doing a little bit of Terraform, a lot of our developers don't want to be dealing with that. They don't want to know, because it works very differently from app development, the state files, running it locally. So hopefully we can pull that one layer down into the platform. Yeah. And our experiments so far have been pretty good. It does rely on, what do they call it? It's gone now. The reconciliation loop, but you can add weights. So it can look like your whole pipeline is waiting for everything to be deployed. But if you're feeling really advantageous, you can rely on the reconciliation loop, and it'll appear when it appears. Yeah.
I'm assuming you did a comparison between like credits and crossplay. Teams thoughts on that and why you chose credits over the other?
I wasn't part of that investigation with the cross-plane bit, but we had looked at it, that's for sure. And I think what we liked about Cratix was that you wrote your own promises. So it meant that you would end up with a Stack Overflow specific implementation rather than kind of like whatever the industry operators come down with in cross-plane. Yeah.
Okay. Can I ask you a more philosophical question?
Sure.
You mentioned halfway through, well, not about a third of the way through, that you think, well, I mean, I don't want to put words in your mouth.
Please.
You're talking about you build it, we own it as
Yeah.
a philosophy.
Yeah.
What has happened to that? Where do you think we are on that philosophy now?
It depends on who you're working with, to be honest. I think it depends on the engineering team. Previous places I worked at, for example, when I worked at Monzo, the you build it, you run it was very key there. The developers knew everything from the ground up. They'd write Cassandra, they'd write manifest, whatever. But other places I've worked, the developers want to focus. They want to focus on product stuff. They don't want to deal with things that's not part of their remit, and I get it. Initially, I didn't. Initially, I was like, why? It's all part of your app. But they want to focus, and you've only got so much brain space. So depending on how your tech team appetite is, you could be at either end. And one of the things with the platform engineering approach is that even though you abstract things away, like behind these Cratix promises, it's not going to be hidden. It's all going to be like open. You can see the promise. You can see what's written in it. You can write your own promise. You don't even have to use it if you don't want to. If you want to write straight into Terraform, you can. And we're not going to enforce any of that stuff. Hopefully it looks easy enough that people want to use it. So my philosophy is, yeah, it depends on the appetite of the development team you've got, combined with having a open way of developing that platform so that you don't get shadow IT, basically. That's the alternative.
Yeah, do you think because one of the reasons I think originally if you build it, you own it, was this, a principle that if developers didn't own it, I don't want to use a bad word, but okay, you just shit on basically.
Yeah,
What do you think we trade off? How do we fix that trade-off if we move away from that model?
Well, that's why it becomes more of a service and that's a provided. So you're hoping the developers will treat it the way that you treat Azure and GCP, but one level up. So you don't really shit on Azure, you don't really, well, you can do, I suppose. But you have more of a working agreement, I suppose. But the lines are clearer too. You know, if there's something wrong with the content of that promise, that's definitely the infra team to fix. But if there's anything wrong with anything above, well, that's yours. So that ownership line, I think, is what makes it easier to work on.
It's helpful with support because you don't want the engineering teams to start supporting the uptime of the Redis server or something else. You have the platform team that has the experience with this. They can help with supporting, maintaining the, enforcing the SLA on this. And engineering teams just have a product where they can just use, and they have a deep connection with the platform team make sure that that's available to them.
For the people at the back of the room, to try and summarize again, sorry, you're just so quiet, it's more about the support part there. You don't want to have every engineer supporting shared tooling like Redis and so on and so forth. So by adding this separation of ownership, you're creating the support ownership layer too, which is quite clear. Is that about right? Yeah. Okay. Sorry. Yay.